So this lovely title really should have been yet another talk about Munki. But instead, we're going to talk about maybe less on the client and more about how we can run an actual web server using Go. For those who haven't met yet, my name is Brandon Fress. I work at Stripe doing CPE things. Okay, so every problem starts with like a problem statement here. Most of you have the same type of problem if you're thinking about monkeys. We need to deploy software, it needs to be secure, and it needs to be reliable. And so we had the same problem with sort of like 3 core requirements that we wanted to sort of address. We've talked about GitOps, same type of core requirement. We need to have all changes in the repo being source control. You build it in CI, it becomes an artifact. Take the artifact, deliver it to your system, deploy it out many times. Because of that, we can't really ship a file system. 2, we know when we have to download something, it's going to be in S3, so we want to use CloudFront. And then lastly, we want to have some good assurances that when a client's connecting in, we know who that client is, and so things like password-based auth just will not work for us. Okay, so we landed on using Go for this, and one of the reasons we wanted to use Go is it has just first-class web support, and it runs really well, and you can get a single compiled binary for your service. 2, we can do centralized CloudFront URL signing, which we'll talk about, and there's an SDK from AWS that helps do this. And then lastly, we can add MTLS pretty easily with about 5 lines of code, and you can add multiple CAs or whatever you want to validate your clients against. Okay, so our web server really has about like 3 endpoints. Your first one's your /repo. This could be any name. I'm just choosing /repo. This is where Munki's going to grab catalogs, manifest, icons, things like that. When it goes more specifically to download a package, that's going to hit a different handler in our service, which is going to generate a pre-signed URL. And then lastly, if you're running in sort of a distributed architecture, you need a health endpoint so that you know your service is ready to accept traffic, or if one's bad, you can sort of like rotate it out. And so we'll implement that as well. Not to labor the point too much, but just a like quick blurb about client signing versus like server side. We sort of addressed doing the client side version, but we didn't want to introduce any extra like middleware dependency. We also didn't want to ship a private key across like thousands of endpoints, and if one of those were compromised, we'd have this major bit of toil to sort of rotate it. And so you flip the model when you do it server side, things become a lot simpler. Munki doesn't need any changes. It will happily follow a redirect. There's one key on one service, and when you need to rotate the key, it's just a change to your YAML file and a redeployment of the service, and sort of off you go. So we'll dig into the web server component. This is like a very like hand-wavy basic Go web server. I'm using a third-party library here called Chi, but it could be, it uses a standard lib. But you'll see our 3 endpoints there. And to the right of them, you're going to see that we're calling these functions, where in Go, they're like really we're calling a handler here to sort of handle this like traffic. And then the last line is just like us starting up the server on a specific port. We'll focus on the /repo path, which is where like we have all of our like repo that you put in Git. Okay, so how do we like ship a file system with Go when we can't attach it to anything? And Go has a really neat thing called the embed package, which was introduced in 2016. And if you take that directory structure on the right, like think of that as your Git repo with all your stuff in it, when the project compiles with those commented out lines above that repo variable, it will traverse that file system and it will compile all those files into the Go binary. It's completely read-only. It's safe to be read concurrently from any Go routines, and you now have a package that anybody in your organization could import your repo and then use the contents in their application if they wanted to. Okay, great. So we have like a read-only file system. It ships each time we make a change. We get a new version of our app. You can't tamper with it because it's read-only. So how do we serve it? Well, we can serve it here using Go with the HTTP file server FS, and then we pass it our Go package here, which satisfies the interface, and then we really call serve HTTP, and then Go just handles it for you. So as long as the request lines up with a file that exists, just like any file server, you're going to get some XML back. So that handles that part of the web server. Next, we got to move on to CloudFront signing, and really this bit of preamble here. It's just sort of like showing you when you're doing CloudFront signing, you really have a private RSA key. You have a public key, which is the key ID that Amazon will give you for that. So we need to read the private key in the first line. Then we just like error check it and type check and make sure we don't have any problems. And then at the very bottom, we're going to pass in the key ID and our private key. And Amazon and their SDK is going to give us back a signer object that we're going to use a little bit later. So now when a request comes in from the Munki client being like, I need to download Google Chrome, we're going to land to this little function here. And this is going to take our signer, our like CloudFront URL, and then Munki is going to be requesting, you know, the package path that you put in your package info file. So this bit of code here takes the CloudFront URL, it takes the package path, it then takes our signer and adds a little bit of like validity, like how long do we want the pre-signed URL to be valid for. Here it says 1 hour, you could do 10 minutes, it's really up to you. You create this pre-signed URL, and then at the very bottom, you're just going to redirect Munki to say, go download this, and it will happily follow it and go download it. Wish me luck, everyone. Here we go. So here I'm going to not do that. Fire up our web server here. This is Munki, and then I'm going to run it against it. Okay, so you're going to see, like, here's all the requests. This is running off the file system here. I'm going to then just like mock a request for the pre-signed URL with curl. I didn't have time to set up an actual real CloudFront distribution, S3 and all that good stuff, but say a request comes in like this for like Chrome, as soon as we hit it, you'll see on the server side that we just return a 307 telling the client's temporary redirect, and then here on the right in the location header, you're going to see we have our pre-front URL, and in typical Munki fashion, it'll just follow it and download it. And the expiration time doesn't really matter as much because once the download starts, if it takes longer than like 10 minutes, it's still going to be valid. Amazon won't just like cut you off if you are downloading, you know, past what the expiration time was on the URL. So with that, that's my talk. If you have questions, feel free to grab me. I'd love to talk more about this and show you more of the code and answer any questions you have. Thanks very much.